Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. This is our first time back actually programming on Handmade Hero. We did some test streams, but this is our first time back programming on Handmade Hero. Since we fixed the streaming machine, and the whole reason we fixed the streaming machine was because we were trying to program a shader and our AMD card was like hard crashing the driver. I don't even really know if we had a bug in the shader. I mean, we certainly hadn't even gotten close to finishing the shader because we were just in the middle of working on it. So it's not like it's done or anything. So it certainly has bugs in the sense that there are whole parts of it that aren't even implemented. But I don't know if there's actually anything in it that was crashy. But we certainly had something in it that was crashy for the old AMD card. So we decided it was time to finally take the step of upgrading to a 2-machine setup, which we did. It took a lot longer than I was expecting to build because we had a bad CPU in the mix, turns out. The streaming setup is 2 Core i7s, 1 in each machine, and one of them was bad, which took forever to try and debug. So that wasn't great, but that, finally got resolved, and now we've done some test streams, and it seems like everything's recording and streaming properly, and we haven't had anything weird happen, like a machine crash in the middle of the stream or anything. So hopefully we can now do some programming on GPU stuff, and if we do crash, it's okay, right? It should not cause any kind of problems. Also, we got some fringe benefits. The fact that now we're streaming using an HDMI capture on a secondary machine also means that we no longer have to worry about weird stuff like when we're trying to profile our game or get the streaming of the game working. We no longer have to do special things to try and work around the fact that like OBS is running in the background, or that the whole window capture is running and interrupting the compositor, and all sorts of other things like this. So it does give us a much more true setup to what it would be like if you were game developing on, just a machine, your own machine, because normally when you're developing, you don't have these constraints. Like, you're not trying to stream the running of the game, and you're not trying to do any sort of weird, coding in with OBS running the background and all those sorts of stuff. So this is more like what a typical dev machine would be if you were using it, so that's also kind of a nice fringe benefit. And obviously we can also, if we do crash the driver, it's no big deal. We can just reboot the machine, and the stream and the recording don't stop. So again, it's a nice way to bring us closer to how it will actually feel if you're doing this on your machine, at home, or working at a company on developing stuff. You don't normally have to worry about those things, and now we don't have to worry about them either. So that's pretty nice. Okay, so I will go ahead and sort of open up the code base here. Now, it's been a long time, so I fully expect everyone to have forgotten what we're doing. So we'll take it pretty slow today. Don't ask me why I remember what we're doing. I probably should have forgotten now as well, but I didn't. So I guess that's good. But I'm going to go ahead and open up 4Coder here and just get the game running and do the various sort of basic startup stuff. So here's our Handmade project. I'm going to go ahead and build it and make sure we're still building and running. Again, we kind of did test this on the test stream. We didn't do any code changes though. But we've got the kind of weird Visual Studio. When I reinstalled Visual Studio, it's Visual Studio, whatever the latest one is. Visual Studio 2049, starring Harrison Ford and Ryan Gosling. So anyway, if we load up the project, I don't know what all this garbage is. I could probably figure out a way to stop it if we look in the settings. But if we load up the game, it's still running correctly, and I believe this is actually also correct because we left off when we were doing lighting, and we hadn't optimized the lighting at all. So if I remember correctly, what we had done is we put the lighting on a switch, and so we it won't actually do any calculations till we hit whatever the hotkey is, and then it would sort of try to run the shader to show it as well. And so that is where we're at, and that's where we're going to go back to here. Now, also note that we have we haven't really done any of the work in the renderer to really fully support what we were trying to do. So there's also some weird artifacts here. Like for example, since this text actually goes through the same shader, we didn't like have anything in the render that switches the text to a separate shader. All of the lighting code is actually running on the text as well. So the text is like when all of the world is black because there are no lights, then you also will get the text appearing black as well. So that's where we're at. Now, if you, let me go bring up the code here. If you take a look at the rendering code that we have, so you can see here at the bottom, we've got sort of how the, where we left off in terms of how we were doing the debugging here. You can actually see what we were sort of trying to do. So the way this was working, just to refresh everyone's memory, is we put in a little, I don't know, like a shunt here, basically, that instead of trying to do lighting on the GPU at first, we were actually just computing lighting on the CPU. So we had this little piece of code here that would take all of the quadrilaterals that we had sent down, right? So normally, when the game's rendering, all of the sprites and all of the cubes that make up the sort of floating landmass, all of those are going down as a set of quadrilaterals that can optionally have textures on them, but they can also, if you want them to be, as the landmasses are at the moment, just be solid color. And the way solid color is implemented is with just, you always do select a texture on every quad, but you can select just a pure white texture. So instead of it being something like grassy or whatever that it would normally be, it can also just be, you know, whatever the color of the quad is and not have any actual texture on it. So that's the way we were implementing that, and you can see here in the extract reflectors from quads function, essentially what we were doing is going through all of those and making little dummy reflector objects, which are sort of these things that we compute the lighting on, and they're just sort of like, we haven't really decided how exactly that's going to work, so we were just playing around with it, and basically what it does is it just puts a bunch of like little elements in the scene that we're going to transfer the light around on, right? It's just a very approximate thing. I think we're using the verts one now, but I'm not sure. I'll go check. Extract reflectors from verts was the same thing, but instead of using this, like the quadrilaterals themselves is where to put it, this one put it at the vertices, right? Or near the vertices. So I think what it did is in the corner or something like that, right? We then have the lighting test function, which would essentially do sort of, you know, a crappy lighting simulation. And the way that this worked was it would go over all of the reflectors, and it would do a lighting computation on them. Now, we had two things we were doing. One of them, there was this approximation of how much each of these reflectors was occluding for like sort of an ambient occlusion thing. And I don't really think we're using that anymore. Could be wrong about that, but I'm not, yeah. I think we sort of decided that was maybe not the most interesting thing to do. And so what I did instead was I ended up putting in shadow casting in here. So effectively what happens is in the compute lighting, when we would actually look at the transfer of light between each of the elements, we actually do hit testing on the lighting elements as well. So that's how that was working. And what that would do is for every one of these lighting elements that we generated, it would sort of store what it thought the end lighting was. And we hadn't done anything fancy here. It was really basic, but it was sort of working, right? It sort of had shadows and it sort of had lighting transfer that made some sense. So it's not completely out to lunch, but it's also not like good or anything yet. We then had output lighting quads, and what output lighting quads does is, well, there's sort of two vert flavors of what we do when we because we compute this lighting on these like intermediate elements. We then need some way of having that actually, you know, go feed back into the rendering so you can actually see it. And you can kind of see here that we have a number of different ways that happens, right? So output lighting quads is one that just, instead of rendering the scene, it actually just hijacks the scene, essentially, and overwrites the scene with just like basically a debug view by taking each of the lighting elements and replacing the quad that it came from with itself, with the lighting element, so that you get to see what we computed for lighting elements. We then had an output lighting verts one, and this was kind of interesting because this actually was kind of cool looking, right? It started to look reasonable, if not particularly good. And what that did was it went through and it took the lighting elements and it put the lighting element information back into each quadrilateral, but each of the vertices of the quadrilateral had the lighting information separate, so that you could get a color wash across things, because it was for when we did extract lighting for vertex lighting elements, we would be computing the lighting near each of the vertices, and so we ended up having sort of a better, a pretty nice lighting thing there, but still not nearly good enough to use. It was just like, okay, that's much better than it was, right? All right. So now we get down to some of the other stuff here. Is what we were trying to work on when we ended up crashing the AMD card. So output texture debug, what this does is this is something that takes sort of a more voxel approach we were starting to work on. And what this was a way of saying, okay, what we want to be able to do is maybe do per pixel lighting on the GPU, where every time we're filling any pixel at all, we want to be able to look up into a lighting table that tells us what the lighting should be around this area, right? So what this does right here, output texture debug, is this is something that just puts that information into the render in a way we can see. So it just goes through each of the, and we haven't gone over like what we're actually talking about here in terms of what's in the voxel grid, but assuming that you have a voxel grid of these dimensions, it goes through each cell in the voxel grid, takes whatever the lighting value was there, and creates a cube in that grid of the in the render stream. It creates an actual cube that will be drawn and puts it there with the lighting color that it should have. And that was basically just so we could see that there was a grid and that values were getting filled in the grid, right? But that doesn't have anything to do with actually using that lighting for per pixel computations. It's just there to create a render stream that we can view if we want to see whether the voxel has valid data in it. That's all it is. All right. So then we've got output lighting textures. Output lighting textures is the actual code that's closer to what we would be doing if we were doing this for real. And again, I don't know that we will do this on the CPU either way. We may do all of the lighting on the GPU, it's hard to say. So doing it for real just means doing the correct set of steps. I don't necessarily mean the way we would necessarily ship it. But point being, what we do for output lighting textures here is we go through and we see for all of our lighting elements that we've got, we go through all of those lighting elements and we figure out what the bounding area is of those lighting elements, because that is the total amount of space that we will have to have covered by our voxel, right? We then go through and figure out how big the voxel has to be, right? So how big each voxel cell has to be to cover that area, because we don't ever change the dimensions, the cell counts, right? There's always the same number of cells in the voxel along X, along Y, and along Z. All we do is stretch how big those cells are so that they properly fit into the, so that it properly covers the entirety of the lighting elements that are involved. We then go through each of the elements themselves. We look to see where we would have to place those elements in the voxel, and we place them into the voxel. You can see here we sort of grab out whatever the emission value was of that lighting element, and it looks like what we're doing here is saying, I'm I'm not really sure what this is meant to be doing here, but it looks like we're looking for a bright emitter just to find one bright emitter, right? Like debug X, debug Y here. So I'm not sure what, I don't quite remember what we were doing with our debug X, debug Y, debug Z. We were just wanting to see some emitter that had a, I guess it's not really brightness, it's the radius. So we were looking for a large emitter. I'm not sure why we were bothering with this, but that's one of those things we can look back at the annotated guide if we need to know, I suppose. But anyway, as we go through these, what we were doing is we're saying for each of the elements, we daisy chained them effectively into their location in the grid, right? So we take a look at each element in series and we put them into the lighting at their correct voxel grid by creating a linked list at each voxel location, right? And that was substantively what we were doing. Now, I don't know where our actual... The only thing that's a little bit weird there is I'm not sure... Okay, so we were. So in line, I was like, I'm not sure where we're doing the thing that actually packs it into a texture, but I do now know. It's just done right there. So in addition to that, we also sort of had a format for this texture, right? And you can see that happening here, sort of. We're actually packing these down to 16-bit values here. So if we take a look, I assume that is in our render structure here. Let's go ahead and take a look. Do we not have this spec'd out somewhere? I feel like we should. This part, I don't remember. Yeah, I don't see where we actually, if I guess I should say, we actually defined it anywhere what we were doing with that. But so you can kind of see how we were doing this, right? Well, there it is. So it's we know that that's a dest. We know that the dest texture is it's lighting textures, right? Dest, and you can see it looking at the pnext texture. So that should be in here, right? Lighting textures. So it is here. It's in Handmade platform, though. Ah, right, because it has to be accessed by the OpenGL code. So yeah, that makes sense. All right, so anyway, this was the actual thing we were building, right? And this is, you know, in kind of a wonky format because it's designed to be read by the card. And so the idea here is that here is the voxel and here is a index, right? Like, so this is basically a texture, a three-dimensional texture of 16-bit values. Each 16-bit value is just a lookup into this other, you know, sort of it's sort of a voxel lookup into just a big linear list of information, right? So if we go to this this lighting texel here called pnext, what that is it's a thing that says what the position is and what the next value was, right? And similarly, I believe that this is a parallel texture here, right? So we basically have two textures, two 32-bit textures. One that not 32-bit texture, sorry. We have one texture that is 4 32-bit values, right? X, Y, and Z of the position of the lighting element, and a next value, which is just an actual index into the pnext array, right? This could actually be a U16, but we don't have any reason for it to be at the moment because we can't use the 16 for anything else. And then we've got another parallel array here that is a color for each of these, right? So by looking up into pnext and C, you can find out both what the position of the light is, the color of the light is, and whatever the next light element would be in this voxel, right? So the idea here is that anybody who's trying to render a pixel can do a lookup value. The lookup value is going to tell them what the color is of the light there, what the position of the light is, and then where to look for the next light. And they could just keep going till that value is 0 and know that they've processed all of the lights in that voxel cell. So in theory, what we should be able to do at that point is make it so that when we move a point around in space, it can look up in its location, it can look up the 8 voxels that are around where it is as a sort of bilinear blend and take all into account all of the lighting elements that are in that area, and that can be the lighting value for the pixel, right? That's the entirety of the scheme. It's not particularly exciting. So, you know, and we've got a hard bound here on 4096 elements because that's how big the texture is that's going to store them all. So if you wanted to, you would have to go in there and be a little bit more specific about how many there are going to be. Like maybe that needs to be a larger array, like maybe that needs to be 8192. Maybe it could, you know, maybe it needs to be 65536. I don't know how big it needs to actually be. Because right now, since we're doing the lighting on the CPU and we don't use any sort of LOD for lighting, we're just computing it like completely n squared, you just can't push the number very high. But when we fix those things, we may want to push the number quite a bit higher than this. And at that point, we would need to expand that texture because we would run out of room in the texture to store the lighting. So that's about it. That's where we're at. And like I said, I don't have anything in particular I want to do today. We're just sort of getting back into it. So let's just go ahead and relook up. If I remember correctly, like I said, the way this worked is we had sort of a lighting operation that we would do here. And I thought that what happened there was that, yeah, you can see we have our F key input thing here. So I believe what happens is when you push the F key, we'll compute the lighting and we'll send it down. Let me just verify that that's true. And then we can go ahead and try to start to try and get that working again. So you can see here that we check all the F keys. So F1 is the first F key. And it looks like we've got, yeah, 2 places where that happens. You can see the lighting test getting called here. So in theory, if we just press F1, it will do the lighting. This is what crashed the computer. Well, it didn't really crash the computer, it crashed the graphics driver, I guess, last time, which was enough to take down the stream. So if I push it, you know, we pause. And here I've done the lighting computation. You can see all of the voxel cubes here that I guess were from when we before the stream got crashed out. I don't know if we had like reverted it from that or what had happened, because I'm not sure this is actually running the exact code path that crashed the stream last time. But yeah, you get the idea. So this is the one that outputs all the cubes. And I believe all these cubes are currently using the shader that, if they're all black, like, and they're not showing any color, because I think all these should have their lighting color associated with them now. I think that means that the NVIDIA card just doesn't crash on the shader, because I think it means the shader is actually running, right? I think that means that. Now I'll go verify that fact, but I think that means we left the code as is, basically. I'm not positive about that, though. That may not be true. All right, so let's go over to OpenGL and see what's up with that. And we can also, I think we installed RenderDoc on this machine, and it will work, unlike before when we didn't have any way to do graphics debugging. So we'll also be able to use a debugger on the graphics now, which is really nice, actually. So anyway. So let's take a look at what's going on here. So this, I believe, is, yeah, so this is the main shader, right? This is the Z-bias program. And what you can see here is it does have the while loop for lighting right in it, right? So we are actually running this. We are doing these texel fetches. We are, yeah, we're doing everything exactly like what we planned to do and what had crashed the stream, I think. But don't quote me on that. It may be that this is not actually doing. It may be that we like commented something out that was crashing it. I don't quite exactly remember that, right? So it looks like what we were doing at the end of this is just seeing whether this loop worked at all. What's odd about this is it looks like we're stuffing the green value, right? You can see this here. And so what's odd about this loop is what it looks like is going on here is it looks like this lighting index is just coming back 0 right away, right? In other words, I'm assuming that if I went ahead and did this, where you can see I've got a light color here that's being stuffed to red. If I was to get inside this loop, I would stuff green. And I'm assuming that what I'll do here is I'll always just see red, right? So here's before we've computed any lighting. Now I press the F key, I've computed lighting, but there are no green elements, right? So there's never a pixel that thinks it ever got a lighting value, no matter what happens. So yeah, obviously not great. We need to figure out why our texture situation is not doing anything, right? Like why are we not getting anything? Before I dive too far into that, what I would like to do is, and I can set this back to black now that we know that's the case. What I'd like to do is see what we have in terms of debugging capabilities now. Since we have the ability to use a graphics debugger, I think now would be a good time to show how to use one, because like I've said many times in the stream before, if you do have one, you want to use it. If you don't have one, you don't have one, so that's not an issue. But we do have one in this case. We've got RenderDoc, and what we can do with a tool like this, again, since we tried to use one on the stream before, so you remember us trying to, but we couldn't. What we can do with a cool tool like this is run it, and what these tools effectively do is they will patch calls to the driver to capture the state of the graphics library as it runs. So effectively, like, you know, if you think about OpenGL, right? When the OpenGL driver is running, you know, there's a bunch of calls to OpenGL that would allow us to say, read back what the texture is at a particular texture location, or read back the state of a vertex buffer call, or read back this, read back that, right? So there's a lot of ways we can go get information from the graphics card. Also, from an external point of view, if you imagine what happens in the executable, in our executable, we ask the driver for all of those calls to OpenGL, right? And we're calling into the driver with OpenGL calls asking it to do stuff. What tools like this do is they can insert themselves in between the driver and those calls so that they also know they can record every call we made and capture the information we were pointing to from that call, right? So basically what happens is these tools are sort of recorders that just sit in between your executable and the graphics driver, record everything you ask the graphics driver to do, and by looking at all of those things that you ask the driver to do, it can also know what calls to make to the driver to grab out various textures and other things that it can then store to show you the state of the program as it goes, right? More sophisticated ones can also do stuff like replaying the graphic stream up to a particular point so that you can see the state of like a specific buffer or something at that point, and all sorts of other things like that. So it's, you know, like if you just understand that basic working, then you can kind of imagine all the things that they can do. So it's kind of nice to have something like that around. Yeah, and it just helps a lot with graphics debugging, as you'll see. So we made a profile here when we sort of tested this out on the test stream. And basically all you have to do to run one of these programs on your executable is you just have to fill out some information here, just like you would in the debug settings of like Visual Studio that we did for debugging it, right? It needs to know where the executable is. It needs to know what directory the executable should start up in. And then it needs to know any other information that you would normally pass. Now, we don't have any command line arguments or environment variables that are relevant to the program, so we don't have to worry about those, but if you did, you would put them in here. So that's all we really need to do. And then once we have that going, what these tools generally do, and again, if there's more than one of them. Nsight is another one that I have used a bunch that's for NVIDIA cards specifically. We're using this one because it's a little more like sort of cross-vendor, right? So if you have an AMD card out there, you should be able to use this as well. You don't have to have an NVIDIA card for it specifically. So once you have one of these all set up, I can't tell right now. Yeah, I was gonna say my head is hiding, so I'm gonna have to do this, the launch and close buttons. So once we have it all set up, we need to hit this launch button. And what that should do is it should run our program, right? Now, thankfully, RenderDoc has built into it the concept that it's not really recording everything all the time. All it's doing is just watching, right? And you can see that it's added an overlay here. And this overlay, like I said, since it's hooked into our application and intercepting our calls to the driver, what it can also do is insert its own rendering into our rendering, right? It can insert some calls that render this overlay, and so that's exactly what it has done here, right? So once we get in a state where we actually want to capture, you can see it says what the instructions are right here. You just print F12, you hit F12 or print screen to start the capture, right? And that will capture whatever frame we were on that time. Oh, excuse me. Tired today. Now, we don't want to capture a frame yet because we haven't sent the lighting textures down to the card at all. So it wouldn't really do us any good to look now because we expect those textures to be zeroed. So first what I need to do is hit F1 so that we know that we've actually run the lighting, in theory at least, sent it down. You can see that this got a lot slower here, but I think that's probably just because we have a lot more cues. I'm not really sure why it's slower. We haven't done any work to see why it is. But you can kind of see that it's like, it's pretty pokey. I'm not sure why that is. That might be something to do with RenderDoc itself. I'm not sure. But anyway, then I'm going to go ahead and hit F12 to get a capture on that. You can see it kind of pauses for a second. Capturing a frame takes a lot more time, right? And the reason for that is because, again, it's got to intercept all those calls and record data. But we've done that now. And so we should be able to close the application. And you can see here it loading up what it captured and processing it. So we got to give that a second. Hopefully it works. But now, once you do that, you can see you get a lot of really great information. That's why I say these tools are really nice. If you have one, you should use it. If one works on your card or your console or whatever you're programming on, because you can kind of see that we've got like a lot of information already about just what's going on. Like even just this is sort of a nice thing to see because it's kind of just like stepping through your own program in the debugger. You get to see like exactly what it does unambiguously, right? You always think you know what your program does because you wrote it, but you don't always know whether you're thinking about it correctly. Now, unfortunately, RenderDoc seems to be a little janky here. Like I can barely even use it. I think probably because it's trying to do too much background processing to update something. I'm not sure, but well, yeah. So I don't know. Maybe we will have to use Nsight because this is pretty bad, right? Like this is not really usable here for whatever reason. Like I can't really click on anything. You know what I'm saying? And like I said, I think I said this on the test stream. I've never used RenderDoc, so I'm the wrong one to say what should happen in a circumstance like this where it's not acting particularly nicely. You can see that it's sort of just freaking out all the time. Like I can't even really interact with it hardly at all. So yeah, I don't know why that is, but I guess that's a non-starter. Hello? Hello? Yeah, so anyway, if you can get RenderDoc to work, go for it. That is about the experience I normally have with RenderDoc, which is why I tend to use Nsight, because Nsight doesn't seem to have quite so much that kind of a problem. So that's why I've never really gotten into RenderDoc, is because I've just never really gotten it to work. So I'm gonna go ahead and put Nsight on here instead. That is not okay. I'm gonna click on this anyway. This is not the Nsight you want. We do not need Life in Digital brought to you by Nsight. That is not actually what we want. We want this one. So what this does is, if you download this one here, Nsight Visual Studio Edition, unfortunately they don't have a version that runs outside Visual Studio, so you kind of have to use Visual Studio with it. This is really unfortunate because, you know, I would rather it just kind of be a standalone thing. But unfortunately it's not. So I'm going to go ahead and download it here. I don't think that actually downloaded anything. I think all you need is this, because I think we already have a driver. I don't know if we do or not. While this is downloading, all right. So I guess I need to log in as a member. So as far as I know, this is not hard to do. I assume that this is pretty straightforward. Like, I did not have to do anything special for that, but it looks like I will have to actually download it this way. If you hold on 1 second, though, I can do that pretty easily. Helpfully, I already have exactly such a developer account. Now, why you need a developer account in order to download this tool, I have no idea. That's a good question. If anyone from NVIDIA happens to be watching the show and wanted to tell me what the point is, that would be great, because it just seems superfluous. But if I look up my login here, I know I've got it somewhere. There we go. So if I go ahead here, let's try to log in. Let's go ahead and log in as me. And unfortunately, I do use gigantic, impossible passwords, even for things like this, where it doesn't matter if anyone steals your password, because it's literally a junk account that is used only for downloading Nsight. But oh well. Hopefully I typed that correctly. And off we go. All right, so we need to download this here, but I don't know how to do that still, because where did the download go? Here we go, downloads, download, download, there we go. So now we've got it downloaded, and the only thing that we have to verify is that we have a driver that's late enough, because it did say that was important. I'm gonna put this away. that was only necessary for looking that up. There we go. Just slide on back there. Okay. So in theory now we've got Nsight and we can try that one instead. Because like I said, I would like to have a debugger, and since RenderDoc doesn't work, I think we might as well switch to Nsight. Like I said, even though I had, like, that was not some kind of thing that NVIDIA gave me special, that's just like anyone who goes to their little join now thing can create one of these accounts and use Nsight as far as I know. There's no like special, you don't have to be some kind of a like provable game developer to do it, as far as I know. So the only thing that I wanted to check here was those requirements there. They said like something about having to have the right version. Don't quite remember where we saw that. Was it the page before here? Let's see. Because I'll go check the version of our graphics driver. Is it on here? Here we go. NVIDIA display driver 38494 or newer. So let's just verify that that's what we've got. So this is 38205, which is, I guess, pretty old then. I mean, well, not that old, I guess, but definitely not the one they recommended. So let's go ahead and update that, because again, this is one of the nice benefits of having a stream that doesn't go down if we want to reboot the machine. So let's go ahead and do that. This is a GeForce 1080 card. There we go. We don't actually need to do this because it's all one integrated driver, but I think they just want to collect product information, I guess. All right, so 388.0 is quite a bit later than what we have, and definitely later than the one they recommended, right? Because they said 384, if I remember correctly. These are hard to keep straight. They said 384.94 or newer. This would be 388. So off we go. We will agree and download. And now, in theory, we should be able to update the graphics driver. Sure. Waiting. Well, this is exciting. How big is this graphics driver? 440 megabytes compressed for the graphics driver. I suppose that's probably because there's lots of like patch stuff in there, and like here's like 800,000 games we've hand optimized and all of the shaders that we repatch and all that stuff. So it's probably not the graphics driver that's that size. It's probably like a ton of like data for every application. Checking system compatibility. Okay. We do want a graphics driver. I don't know what that is or that. I definitely don't want a GeForce Experience or PhysX. That's interesting. So there's a GTX 1080, I'm sorry, 1070 Ti. I'm not sure what that means. I don't know what the Ti means. I just thought it was some like branding thing, right? That's like, oh, it's, you know, the 1080 is good, but like the 1080 Ti is like really good. But I guess now we've got a 1070 Ti. So then the question is a 1070 Ti better than a 1080? I assume it's not better than a 1080 Ti, but I don't know if it's better than a 1080 regular. What does the Ti mean? It's anyone's guess, really. Now we're getting some nice ads here for some random games, which is always good. Does this let me pick between them? So I can do like Destiny, Shadow of War, Destiny, Shadow of War, Titanium 1070. What if I wanted to learn more about this? What if behind this learn more button, look at. There we go. We got a speed boost there. That was like in Mario Kart where you hit the little thing that like boosts you forward. Okay, there we go. So now we should be good to go, hopefully. If Windows doesn't like. So that's interesting. I guess we'll have to remember that. Updating the graphics driver, it will reinstall effectively the HDMI sound output, right? And that's actually a problem because what Windows does in that situation is it will then revert this setting, which is the way we're getting output. So I always got to make sure I check to see if I'm getting output, but luckily I did there. So it looks like it's back, and hopefully it should be fine. That's fine, right? Yeah. All right, so I think we are now okay. I'm going to go ahead and ask it to install Nsight. And here is a giant license agreement that no one could possibly understand, and I don't even know if this is enforceable in court because how any normal person who isn't a lawyer would have any idea what they're agreeing to, I don't know. I would really like someone to test that in court someday. But I'm going to go in here to customize and just make sure that everything makes sense. I don't know what these things are. We probably don't really need this, but we might as well put it on there. Who knows? Maybe someday we will need it. That's a friendly looking name. So now, if we're not completely wrong about this, we should be able to use the Nsight utility anytime we want to profile stuff. Now, we, again, don't really know whether that's true or not because we haven't tried it yet on this machine because we were going to try and use RenderDoc. Unfortunately, RenderDoc didn't really work, which, like I said, is kind of par for the course for RenderDoc, unfortunately. That's just the experience I've always had with it. And so if I now go to Visual Studio and we go to our project, we should now have additional options now that Nsight is installed. So you can see here Nsight is got its own drop-down that's put in here. And one of the options that we have is Start Graphics Debugging. So like normally when we hit debug and we do start debugging with F5, that would run just regular. But now, if we want to, we can say start graphics debugging. And if we do start graphics debugging, yeah, you can, we don't care if it's secure. If you do start graphics debugging, then in theory what should happen is it should launch our application with the Nsight HUD enabled, right? And you can see that that's actually exactly what's going on here. So, now the application's running. It's showing us some performance information, which is nice. If we're trying to optimize the game, right, this can tell us information about that. And if I run the lighting thing, you can see that we've go ahead and run that. Now, you'll notice RenderDoc slowed to a crawl when we were in this mode, but Nsight's just humming along, which is kind of nice, right? So now if I go over here into the, if I, Alt-Tab back to Visual Studio while the game is still running, what you'll notice is there is a thing that says pause and capture frame. And so if I want to, I can just now do the same thing we were trying to do with RenderDoc, get a frame of data and take a look at it. So if I hit that, it's going to take a little bit because it's got to actually figure out, like I said, the same things that RenderDoc had to, where it's got to go through each sort of step of the program and grab all the information that it needs. Who knows how long that will take. But hopefully it'll finish at some point. All right, there we go. It's got this weird HUD thing here, but I never use this because it doesn't work on my actual dev machine. I've never gotten it to work. I think because I use a multi-monitor setup and maybe it doesn't handle a multi-monitor setup or something, but it literally doesn't work at all. So I never use that. I always use the other part of it, which I don't know how to get back to here. Of course, on multi-mon, usually don't have to care. Hello, computer. So I'm not sure exactly what's going on here. The HUD on this machine works. You can see here I'm running through all of the events, like every quad that gets drawn we can look at separately, right? Which is pretty great. Except, I mean, for the fact that the only reason that's the case is because we never did a texture atlas to pack our textures, but that's a separate issue. So the HUD is actually working here, but unfortunately, I don't actually know how to get back to Visual Studio. Like if I Alt-Tab to Visual Studio, it does not bring it up. Is there some way I can force it to minimize? Again, like I said, on my main dev machine, I don't have this problem because I have the debugger pops up on the other monitor, so I've never tried to figure out why it wouldn't let me view it. So we kind of have opposite problems. On this machine, the HUD works, but I can't get back to Visual Studio, which is not great. There must be some way. So I guess one thing I could do... Oh. So by killing the application, I am was actually able to get back here? Except I didn't kill the application. I hit Alt F4, the application's still here, so I guess that just killed the HUD? I don't know. That is very peculiar, and not at all how it works on my dev machine, but okay. I guess that's alright. I'm not too worried about it. As long as we get something working, that's fine. Point being, when you actually can get back to Visual Studio, which I guess we can, so that's good. What you can see here is it adds a bunch more windows to your IDE, right? And these things are basically the same sorts of things that we had in RenderDoc, only unlike RenderDoc, we can actually interact with them, and so we can actually get some information out of them. And what you can see is you get a lot of pretty good information. If you take a look up here, this thing called the scrubber, that's sort of the equivalent of the event list thing. It's like saying, here's all the things that happened. And you can kind of go between them. I don't think they update over here. Maybe they do if you don't have to do the Alt F4 to kill the app thing. But the point is, you can scrub through these things, And what you can do is you can look and see what all the information is at the time of any particular dispatch. So for example, for this particular set of this particular quad, you can take a look at what the vertex specifications were. So you've got all the sorts of stuff in here that we were setting up, right? Like here's the vertex format. Here's like GL float, 4 elements of GL float. That was for the position, X, Y, Z, W. We've got 2 elements of GL float for like the textures, right? We've got 4 elements of unsigned byte for the color and that sort of stuff. These are just the vertex stuff that we set up, right? And you could also see like some of the settings we have here, whether, you know, array buffers are enabled or indirect drawing, primitive restart. You know, we're not using these things, so they're off, but it would tell you if they were on. We also have like the generic attributes you can set with like immediate mode or, you know, those sorts of things. You know, everything you want to know about vertex specification will show up in this window, right? The transform view, if you click on that instead, this is basically showing you all the things you can find out about this like dispatch, right? So it's whatever is selected here. These are the parts of it you can see. So if you look at the transform, you can see like it says, you know, was depth clamping on? You know, what's the depth mode? Is it -1 to 1 or 0 to 1, whatever? Here's what the viewport was set to, right? Like 1920 by 1080 and 0 to 1 for the near far clip planes, blah, 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 right? So again, just a lot of good information. It basically really helps with debugging when you just want to know like what's up, right? Here's the vertex shader. So inside the vertex shader, you can see that basically there's no captured information that we've got here. I don't know if that's because we accidentally stopped the running. Oops, I didn't mean to undock that scrubber. So what I can do is see whether if I continue running here, I get it back, or if there's some way to get it back. So it looks like I can't really get it back. We'd like to be able to get that to work. Let me see again. I'm going to just try some other things here. So if I go ahead and do Nsight start graphics debugging again, so now I'm going to window this just to see if that helps. So now that this is in a window, I'm going to go over to that pause and capture frame option, and I'm going to do it. So now, okay, so basically it looks like it was just the fact that it was full screen it couldn't handle. So this is much better now, because you can see too here, if I leave the game, if I don't have to Alt F4 the HUD version of the game replay thing, then the other nice thing is when you scrub through, you get to see everything that's being drawn at the time, right? And I can even do that, like I can make this smaller, right? And I can scrub through these, and I can, right? I can see actually how far I've gone through the drawing process, which is awesome, right? And I guess now that this works on the HUD too, which, like I said, my dev machine, that's not true. But now that this works on the HUD as well, it means that you can actually scrub it on the HUD. And I don't know if it's smart enough to keep them synced. It might be. I don't think it is. So if I set this one, it does set this one. If I set this one, no, it does. All right, so it is smart enough to keep them synced as well. So if I come out to here, right, I'm on 3877. It'll set it to 3877 here. So for our purposes, that doesn't really super matter at the moment, right? Because we're not trying to debug a specific part of the drawing. But you can imagine why that would be nice if you had a specific thing that was messed up. You can imagine wanting to like dial into just where that was, so that, you know, you're not just hunting through a giant thing of garbage. Now there's other ways you can do that. There's things called debug markers you can output in the OpenGL stream, specifically for purposes like this where you have an integrated debugger. And so if we were trying to nail something specific that was not visual, like this is good for finding visual errors. If there's a particular draw call we wanted to debug or something, there's also ways we can do that. We can go in and insert a debug marker into the debug stream, and it would show up as something we could jump to here, right? So this right here allows us to show some various things about what gets set and what gets changed, right? But we don't really care about that at the moment. So anyway, let's take a look at here if I can now look at the vertex shader. Yeah, so I can. So since I didn't have to Alt F4 out of the window, this is what I was expecting to see here. So you can see that if we if we select vertex shader, we can actually open out the source code for the vertex shader as well. And this is just what we fed to, what we fed to the graphics card when we sent down the shader, right? Yeah, we can look at basically anything we want there. These here, which are kind of the more important part usually because we kind of know what text we sent down, these here are the uniform values at the time. And this is really great too because it lets me see, right, what like the transform matrix was, so I can verify that we sent that down right at a particular draw call. It lets me see like what we set for the fog values, like our special values that we set are all here. And that's really great, right? It's so much more visible than we had before. For the raster ops, this is just a thing that says, okay, how is our triangles going to get filled, right? So, what's the culling state? What's the line state, point state? Is rasterizer discard enabled? Is smoothing enabled? Is multi-sampling on, right? It is in our case. Everything you want to know here. We've got the fragment shader, which is the same as we had been, expecting it to be, right? This is the fragment shader we're expecting, and this is the fragment shader that has our while loop in it, right? And so now the interesting part and the thing that I actually wanted to get to is that these pieces of information here, this is exactly what I wanted the debugger for. Like, first of all, we can actually see all of the information that we set in our shader, like what the voxel dimensions are and those sorts of things. And it looks like those aren't set properly either. So that's probably a big problem. We got to make sure those are set. But the other thing is, the thing that I really wanted to see, that's kind of hard to debug normally, is I'd like to know what is contained in our samplers, right? So what textures are actually loaded, and what do those textures look like, right? So what we can see here, just right off the bat, one of the nice things about it is we can see, for example, our depth map, right? Or other things like that. We can look at the various things that we've rendered, which are kind of interesting, in our depth peels, right? And stuff like that. So we can see all of that sort of stuff in here, and that's just really informational when we're debugging. It really helps figure out what's going on when we have bugs. So I really like that part of it, right? So let's go ahead and actually try a debugging step here. First of all, I think I want to fix this voxel.dim vox main corner thing while I'm looking at it, because that should have been set and isn't set. So you can see here, this is the attempt to set it. Vox main corner and vox dim are being set to these OpenGL constant values here. I don't know, maybe those never got set or something. We'll have to see what the deal is. Here's where they should have been getting set, it looks like. When we get the lighting entry transfer, we're pulling it out there. And so in theory, right, when we call this push lighting, that information should have been set right here. Now, why it wasn't set, I'm not sure, but that's what we're going to have to find out. Now, what may have happened there, and let's just verify it, is I may not have run the lighting, because this was just my test to see if I could get it working in windowed mode there. So let's go to windowed mode again. Let's run the lighting, and maybe now when I pause and capture frame, we may find that those are set properly. Because it may be that I don't think I did. Ooh. What happened here? It looks like it can't write to the end of the peak message block. Why would that be the case? Okay. What is going on here? How come I can't view the disassembly of our code? Is this some kind of Visual Studio 2017 nonsense? Or is that just because I can't debug something that has Nsight running in it? Maybe? Let's hope that's the case, because if I lost the ability to view debug mode, I don't even know what to say about that. This is looking sketchy. This is looking sketchy. Let me reboot this. One thing I will say is Nsight does crash on me fairly frequently on my dev machine, so that's not surprising. That's just something I live with. I'm not sure why it crashes so frequently, or like what is the cause of those crashes, but it definitely crashes. So you will have to sort of expect that. It was not as bad as RenderDoc in terms of like the whole like not being able to use it thing, but it definitely had issues. All right. So it looks like I can't Alt-Tab between it for some reason. One thing I do wonder too, I'm interested to know. So in build.bat, we've got this handmade streaming thing. And if I remember correctly, that was like a workaround for the fact that we had to sort of change the double buffering modes and stuff like this. So I'm wondering if maybe also if we got rid of that, it might help, because the normal way to run it is not with double buffering off. So we can get rid of that now because we don't have to worry about that workaround for streaming. So we can basically get rid of references to handmade streaming in the code base entirely. We can always use double buffer in our pixel format. And we can get rid of the sort of go-to no streaming set compiler flags nonsense. So this stuff can get out of there, right? However, I don't know that we ever actually set handmade streaming to 1, because we never would have set that. Well, actually, maybe we did in the shell. Let's find out. So we never set that in the shell anyway. So double buffering would have been running already, I guess. And I don't know about this to do here. Can we just build both with one exe? I'm not sure what that was referring to anyway, so I'm going to get rid of that as well. Yeah, so... So yeah, I don't know. It just looks like we can't Alt-Tab between them, but I'm not sure why. It looks like Nsight breaks that. So I guess I just won't do that. Just have to remember not to. I sent a report. All right, so let's see here. If I only Alt-Tab once, though, it seemed like it worked. I don't know. Maybe that's wishful thinking. But so if I run the lighting, and then I go here and hit pause and capture frame. Oops, that's wrong. First, I got to start graphics debugging. So if I go ahead and do pause and capture frame, without Alt-Tabbing back, it does not crash. And once I've done that, it looks like I'm fine. So it's just, don't do it before you hit pause and capture frame, I guess. So yeah, I don't know. Hopefully that's reliable. I don't know if it will be, but let's just hope that it is, and go from there. So there's the lighting, and the Alt tab back, pause and capture frame. So it looks like maybe I can't do it if I have run the lighting capture. Why would it need to launch this? What is it doing? I feel like it's launching a second copy of the executable or something. Would everyone agree with that? It looks like it's launching a second copy of the executable. I'm going to take a look on here and see what's up. So here's the section that we would pop up in. So let me go ahead and pin this. So if I go ahead and run, here we go. So there's our Win32 Handmade right there. I run the lighting, I Alt tab, I hit pause and capture frame. So it looks like I did not even actually have to like, I don't think I ever actually clicked pause and capture frame. So maybe it didn't, I don't know. That's pretty bizarre. So I'm gonna hit debug. Sure, launch another copy if you want to. Where are we crashing? I don't even want to know. So here's the NVIDIA graphics stack. Where are the threads? This is what crashed? This is the only thread we get? Yeah. Well, this does create a bit of a problem. If we can't ever actually get it to stably be able to not crash, I mean, hopefully this is just whatever we're specifying erroneously that is the reason why we crashed the AMD driver. Maybe this is also what crashes this driver. Like maybe when we're specifying those textures, we're specifying them incorrectly or something like this. I don't know. But I'm not sure how we can debug this much further. So the first thing I'm going to do here, because I don't have any other ideas, is I'm going to take a look to see if there's something I can do to maybe make things more stable. So when we send down the lighting, ooh, I'm very tired. When we set down the lighting, it's right here. And what you can see is we specify these textures here. I'm trying to figure out, is there something that we're doing in here that's causing the problem? So, for example, let's suppose we just didn't send those down. I'm just trying to guess what we might be doing that could cause the faulting, right? So let's suppose I did that. So I've rebuilt now where I've got a version that doesn't even send down any textures at all. And now I'm gonna start debugging again. Run the lighting. Everything appears temporarily normal. Come back here. See, what's really interesting about that is I don't even ever have to click on that, it looks like, right? It looks like it's before I even click on it. All I have to do is just go to the menus. I know that sounds weird, but it really felt like that. So, like if I come back here, for example, see that? All I had to do was click on the Nsight menu and it crashed. Like, all I had to do was that. Why that is, I have no idea. I wonder if there's anything on here that I can do that would cause it to not do that. So I don't see anything particularly useful in here. So I guess this has been a complete bust. We could not really get RenderDoc to work. We cannot really get Nsight to work. And that's unfortunate because, you know, that sort of means that in order to use the graphics debugger, you have to already have debugged your graphics. Assuming that it's something that we're doing. I don't actually know that. It could be that it's not. It could be that it has nothing to do with us and these would just crash anyway. But assuming that there's something we're doing buggy and that is the reason why we are crashing, then it's like a catch-22. It's like, hey, I'd like to use a graphics debugger to help debug my program. It's like, oh, sorry, you have to already have debugged your graphics in order to use the graphics debugger. Like, all right, well, that's less useful. So I'm just going to poke at this a little bit longer just to see what we can learn about it. If I go ahead and run my program, I'm assuming that that doesn't happen normally. No, it does. So basically, something about the instrumentation, and we're getting a really weird crash in there that I don't super understand. And the fact that I can't ever get any disassembly on my application is freaking me out too. Like, you know, I should be able to go to a disassembly of this. And okay, so I can. So I am able to get the disassembly. I am able to get the disassembly if I just don't have Nsight running. That's less of a problem. so let's figure out what's going on here. I'm trying to get a handle on what's happening here. So if we take a look at this code here, this timed block peak message bit, what I'm assuming is that this bit here is the part that has to do with finishing this timed block. The reason that I think that, just so for folks who aren't assembly language reading sorts of people, is I'm taking a look here and you see this locked add, right? The lock prefix instruction is the thing that lets us know that we're doing a multi-threaded operation here, which, the call to peak message occurring right here, we know that that has no such things, right? That's going to call into Windows. If they had any synchronization, it'd be behind that call. And then we're picking up the value from it. But then we go right into this locked add. And so if we take a look at what happens in the debug code, the timed block function, it creates one of these little automatic things that like creates and destroys itself. You can see it does a begin block and then an end block, right? And so what we want to do is look at the end block call for wherever that is. Right here. And that records a debug event. And record debug event is this code right here. Right? So this RDTSC that you see there that reads the clock value, that's right here. And no one else is going to be doing an RDTSC, right? So this is the reading of the clock value right here. You can see there's an imul. That imul is going to be probably for this referencing off the array here, right? And you can see the locked add. The locked add is this atomic add U64, right? So this all fits the profile exactly of what I would have expected the ending of time block to be. And so that's what I think I'm looking at. Even though the source code, Visual Studio did a very poor job of telling me that this was the destructor. It should have said, right, this timed block part should have been like right there, because that's what this code came from, but it's too dumb to do that. So anyway, what I'm seeing here is that, after this compare and jump here, it's this assertion is what's happening. So essentially what's crashing the application is not really a crash. It's an assertion that we don't run out of space for our debug event table. Like, that's what actually happened. So I guess what's happening is something about the way we're running it right now is causing our debug events to pile up and overflow. So we're adding debug events, and we're never like clearing out the debug events. That's what's basically happening. Why that's happening, we don't know, but it is happening. So we got two options. The first thing we can do is probably the easiest, just to fix things now, but then we're going to have to figure out what to do about it later. So what we want to do here is just say, oh, okay, well, let's just turn off Handmade internal, right? At that point, we won't have any debug events in the first place, so then we shouldn't have any problem. So here's the graphics debugging running. I launched the lighting, done. And then I click back here, and it's all good. So it looks like if we Alt-Tab away, we stop getting those debug events cleared. I don't know exactly why that would be, but it must have something to do with the fact that we're no longer getting a swap message, but we are on some other threads or something doing work that creates debug messages. I really don't know. But point being, at least we did figure out how to get it to work, right? So that means we can hit pause and capture frame now. And in theory, that should allow us to inspect the lighting information. Maybe. After all that work. There we go. Yeah, maybe. There we go. So at that point, we are functional, right? And we can look and we can see what the textures are. So in theory, that would allow us to do the debug step I wanted to do, but man, that was a lot of work. So at that point, however, I'm not sure what I want to do now. I'm not sure if I want to actually do the debug, if I want to actually look and see what the debug looks like on the lighting, or if I'd rather go and fix whatever the overflow path is on the debug events. I suppose the more sensible thing is to fix the overflow path on the debug events. Because presumably, if we took a look at the lighting, we wouldn't have time to fix it today anyway. So that depends. So let's just see what's going on here. So we know that the way that these things are cleared, right, is at the end of our Win32 loop. Every time we come through the Win32 loop, we do a sort of a mutex thing here where we swap the debug arrays. Where is that? This is for textures. So it's right here. That's debug frame end. So debug frame end is called substantively every time through the loop. And I don't really know any way that it can avoid being called. I mean, as far as I know, it's going to get called every time. Unless, well, is it inside global pause? No. So basically, there's really no way around it. So how we are still producing debug events without calling through this, I'm not sure. I guess what maybe could happen is if our Windows, let's say Windows is sending us a bunch of messages that we would generate debug information for somehow, like in here, but I don't know that there's any way to do that. Like, I don't know that there's any way in here that would happen. So what we do know is this is the place where it's happening, right? So one thing might be if we ended up in here, right? Let's do this. So just so we can debug it maybe a little bit better, if we were to go ahead and make a counter here that we check so that we could just see how many times through we've gone. So let's say we set like a global here, and we just made a global variable called, you know, I guess I don't really want to set that there. So if I just counted how many times I've gone through this loop, then I wonder if I can just see really easily how many times, you know, when we get that fault, did we get like caught up in this loop somehow, where our peak message is getting like somehow like an infinitely long thing? I'm not sure. But let's just find out if that's the case. All right, so we're launching another debugger for no apparent reason. You know, I don't care about your browse info. Just do whatever you want. So actually, that's not where I wanted to break. I don't actually want to open up that debugger like so. What I want to do actually here is slightly different. What I want to do is I want to do the version that actually broke inside here. Sorry, NVIDIA, for all of these. Does this one work? There it goes. So I don't actually need Nsight to be running, it looks like. And that's great, because that way we can take that out of the equation. So let's take a look at what for counter looks like. So that's massive. So somehow we're getting stuck in this for loop where we come through here, we get an actual message, we process the message, whatever it is, right? And then we are kind of just we're just going forever. And so we're generating a debug message every time. And somehow we got 524,000 Windows messages, right? What I would like to know is, what are these messages? Like, what can I inspect? What messages we're getting that's causing this kind of absurd overflow? So message 1848, let's take a look at that in hex. So OX738. So what message is that exactly, would be my first question. And in order to answer that question, what I'm going to do here is say, let's copy that in. Like, why are we getting that message just spammed at us? And maybe it's not always that message. I mean, we don't know. It could be that every time through we're getting a different message. So what I really probably want to do is log these messages. And you know what? Let's just do that, because it won't take very long. So what I'm going to do here is I'm just creating a global variable, again, just for debug purposes. We'll delete these in a moment, called message buff. And what I'm going to do is I'm going to take the for counter. So every time through this for loop, right, right after we get the message, I'm going to stuff the message into this message buffer. So whatever the message is that we've got, I'm going to stuff it into this buffer. And I'm going to use it like just a rolling, like a ring buffer. I'm just going to write all the way through it. And when I get to the end, I'm just going to loop right back to the beginning. So that's what this mod does here, right? I'm going to take however many there are, and I'm just going to mod by that. So I'm just kind of rolling in a ring around it, right? So this way I can see, you know, are we just getting spammed with this message ad infinitum, or is something else going on? I don't know. But I do know that when I come in here, right, yeah, we can throw that exception. And so now if I pop back out, I can see, you know, what message buff looks like. And it seems pretty clear. I mean, that's pretty much says it all, right? We're just getting spammed with that message, whatever that message is. So the next step is to find out what that message is, right? And I don't know if there's a window message lookup. There's an error lookup, right? That's kind of handy. So if you have a Windows error, you can go in here and you can look it up. But knowing what that message is, that's a little bit harder. However, what we should be able to do, I think, is we should be able to go in and let's take a look here. Here we go. We should be able to use our search project like we do oftentimes in Handmade Hero. We should be able to say like, okay, well, let's just look up where WM mouse move is, right? So here's like, you know, the winuser.h, which has just like all these messages in it, right? So maybe if we're lucky, we can just sort of blindly find that Windows message. You can see they're listed in hex here. So we know the one that we're looking for in hex is 0x738. Oops. And so the first thing you can do is just see whether I find it in WinUser. But sadly, I didn't, right? So the next question is, well, okay, whatever 738 is, you know, I know where the Windows directory is. It's wherever I am right now, right? So here I am. It's this absolutely freaking absurd nonsense that like Windows does now when they install things, right? A completely ridiculous title, but here's like where all the stuff is, I guess. There's like let me just make sure I can find WinUser in here so I'm not crazy. There's WinUser. So if I take this directory, and then I go to find in files, wherever that ended up. There it is. Oh boy, I can't even paste, can I? You've got to be God. They just. All right, I guess I get to find that entire name. So it's program files x86, Windows kits. 10 include UM. So what I'm going to do here is search to see if I can find that Windows message anywhere just by chance, right? This is not a scientific process. I wish it was. But I'm just going to see if I can find it. So here's our find results, and you can see there's a ton of like GUIDs and crap and stuff like this. What I'm going to do is search in here to see if I can find any WMs. I can't. So it's not looking good for us, right? My next thought is, what's WM user set to these days? So actually, yeah, oh, okay, wow. So WM user is set to OX0400. So actually, that I don't know if we've gone over this on Handmade Hero before, so I'll just mention it. So one of the things they did when they originally designed Windows was they have these Windows messages that get passed around, right? Like we get some like WM underscore this, WM underscore that, and they're just ways of the operating systems calling your one callback function and giving it lots of different things that happened, like event types, right? But one of the things they did is they said, well, you know what? We're only going to use a certain segment of those. And we're going to define WM user to be a certain number that above that number, you can make your own messages, right? So WM user, I thought WM user was a lot higher than that, but it's not. So what that means is WM user, that 738 is actually something getting sent by some other app in the system, right? That's not a Windows message. It's some kind of special message registered by somebody, sent to us, I guess. I don't know how to back figure out who sent a message. I don't know that Spy can give us that information, but I'm going to try. So I'm going to fire up Spy++ here, which we've used before in Handmade here. It's just a way of watching the Windows messages come in. So what I'm going to do is I'm going to switch back to Handmade Hero. And I'm going to go ahead and run the application here. So I'm running. And I'm going to go through here and say, all right, where, if I can even get it to go that long. So it looks like we have some kind of a weird lockup. When we Alt Tab away, we stop running. For some reason. But why? Like why was, did you see that? Why is that happening? So something's wrong, but I just don't know what. And so we have to figure out a way to track this down. Because yeah, this is weird, right? Not sure why we don't get a sizing bar on this thing. Anyway, so now in Spy++ though, here's the app running. We should be able to go ahead and just grab the Handmade Hero window. In fact, I could probably even do it this way. And I'm just going to look at the messages. Well, I thought I was going to, but I guess I'm not. So why are we not seeing any messages? If I picked a different one, would I see messages? Is this not Spy 64? Oh, well, there you go. For some reason, even though, I guess maybe it thought, I don't know why it thought we would want to launch the 32-bit version. Assuming that x86, like I want Spy 64, people. I feel like we went through this already on the old machine, but I guess we unfortunately we unfortunately will have to do this work again to figure out how to get SPY 64, the 64-bit version of SPY, because the 32-bit version of SPY can't look at the messages of a 64-bit application, so it's not going to do us any good. So we need the 64-bit edition of SPY, which I thought Visual Studio would have launched, but the fact that it says x86 on it suggests to me that it isn't launching it, and that it's actually launching the 32-bit version, because I think it would say x64 version if it was. I don't know that that's necessarily true. But here's the one I actually wanted. And I'm going to try to pin that out as well. Yeah, see, x64 edition. So that's the one we actually wanted. I'm going to see if I can pin this so that we can run it anytime we want. So we don't have to go through that again. All right, so now, assuming that that was the problem, I should be able to get the messages for this window, which is what I wanted to see in the first place. And yeah, there we go. So there's all our messages. Everything seems to be operating fine right now. So let's take a look at what happens when I go over here and do whatever the bad thing is that didn't like. Doesn't look like I'm crashing though. Of course, that could also be the case that just the fact that WinSpy is looking at it, means it's fine, because it's doing something that, makes that not happen. But you can see that we're mostly getting 84s. These are all 84s. Definitely not 738s or whatever. So that's not really helping. All right, so here if we run this, let's launch the lighting. See if I can get this to crash again. Oh, you know what I also forgot? Our C tray died. That doesn't restart on startup, does it? So we have come to the end. Poor C tray. C tray doesn't last through reboots. I should probably do something about that, huh? Sorry, C-Tray. We have come to the end, but let me just finish what I was doing here because I'm interested to know. So I don't actually want a message search. What I actually want is Windows, and I want to look at this window. Can I do that? Probably not. Anyway, I just want this to be able to crash on us, but I can't seem to do it while Spy is watching. Right? Unfortunately. So, yeah. If I run light, switch, and it does not seem to crash now either. Right? Let me see what happens if I close Spy, run. I don't know what happened here. So I run, light, switch. Yeah, we magically like fixed the problem somewhere. Like whatever the application was that was sending those 728s has stopped sending them. Which is bad because now we can't figure out who it was. Curiouser and curiouser. So let's try running the full graphics debug one. Like so. So that still crashes it. You know, as long as I've got a way to crash it, I think we're good, right? As long as I've got a way to force that situation, I can hopefully find the answer, right? So let me go ahead and run spy again. Maybe if I'm lucky, if I set up spy right now, like so, and hit OK. Cannot find, really? Oh, probably because I gotta refresh it. Go ahead and hit messages, getting all the messages here, right? Oh wait, I forgot to run it under the thing. Try it one more time. Nsight, start graphics debugging. All right, so now we're under the graphics debugger. Refresh the windows. Now we're watching the messages in here. I'm going to switch back to Nsight. Can't quite provoke it. All right. Lighting. Nope. Full screen. Well, so what we know is that we're getting that crazy message and we're getting flooded. We can prevent that pretty easily, so I can fix this particular bug, but I would like to know who is sending it and why. I am interested to know if maybe there's something I could just track myself that would find out what that is. So what I'm going to do here is I'm just going to take a second and I'm going to look and see in the Windows project that where I can search things. I'm going to see about that message structure, what's all the stuff I could get, and then I'll have to also see, I suppose, if there's any queries I can use to get additional information on the message, right? So, you know, this is not going to give me very much, unfortunately. Let me see if there's any information on that. Oh boy. Stack Overflow says there isn't any way to do it, which often means that there actually is a way to do it. There's been multiple times that I've found some sections are like there is no way, and then I find the way. So I'm not sure that's necessarily true. But it usually does mean there's no straightforward way. Yeah. I can't really think of anything offhand. Want to see if anyone had actually... I mean, the things I'm thinking of are not particularly attractive, right? Like, it seems like, okay, so one way to do it would be to try to make something that hooked to everything to find out who, whenever someone calls send message, we get the actual call. We like hook all calls to send message, and then look and see, like, we look and see anyone who's going to send an 0x728 message. Yeah, I don't know. I don't know about that. So I guess at the moment we just fix it, because I'm not sure what else we can actually do. We know that the problem is that we're getting spammed with a particular message that we can't seem to avoid, right? I suppose it could be our message. Like, do we ever send that message anywhere? I'm not sure. I don't think we defined any custom Windows messages, did we? Because we don't have any of that. So it can't be ours, I don't think. We're never using a custom message. So we're not sending it. Someone else would have to be sending it to our window. Maybe we can look at maybe we can look at registration for them. So I don't know if you can iterate over who has registered stuff. I don't think you can. But this is a function called register window message, where you give it a string and it gives you back a message. Well, but it's not one of those. It says it's between OXC1000 and OXF all the way. And so that it could not have been registered through register window message. So if you haven't called register window message, you're not supposed to be sending the message in the first place, because it could conflict with some other message. So you're not supposed to be sending outside your application that 738 message. So this is a real puzzler. I don't know where this message is coming from. I'm not sure. I would really like to know. But either way, we've got different ways we can deal with it. One way we can deal with it is by discarding that particular message, right? Another way we could deal with it is trying to make this thing so that it just never, like, we could do this. So we don't ever time our call to peak message. And so we're not generating debug events. So we won't crash, but we'd still have to sit here processing them all, which isn't great. But, it would in theory fix the problem. So let's see what happens if we do that. So if I start graphics debugging now on the application, run the lighting, Alt tab back, go to Nsight, now we've avoided the crash, right? So that's good. I'm happy about that, but you know, we figured out what the problem was, but it's like, well, I would really like to know who is spamming us with a WM user message outside of the legal range that you're never supposed to cross-app spam. It seems like there's a bug in some other program. And I don't know. Is there a reason our C-tray icon isn't here? By the way. Sure does take a long time. Well, I'll go ahead and start with questions anyway, while we're dealing with this. Best Alloys said, regarding message OX738, and then posted a link. Let's take a look at that link. Okay, copy link address, and I spent a lot of time last week debugging a third-party application that froze up in some places on Windows 10 1703, but worked perfectly on previous versions. Long story short, this application calls peak message many times on every trip around its message loop. As of version 1703, it appears that the window message OX738 is occasionally sent in the internals of peak message. That message goes into the queue, so get message returns immediately, and the loop goes around again. That pegs the CPU at what this is exactly what we just saw. The solution was to patch that component to check whether the message ID is OX738, and if it is, ignore the message by jumping back to right before the get message invocation. Okay, so is Windows itself actually sending something in the WM user range? Have they lost their minds? I mean, I already know they lost their minds. Windows 10 is, you know, an operating system written by children. So I don't know why I'm surprised. If that's really the case, that's nuts. Windows itself should never be sending a WM user range message. That's crazy. Because other applications may have already used that message. Right? That could break all sorts of stuff. So let's hope that's not really the case. All right, let's kill this. Go away. Yes, stop debugging. So if that's really the case, then I might actually say let's filter out message. If other people are seeing this happen, then 738 should definitely get filtered. But the problem is that, I mean, how do we filter it effectively, right? Like, I mean, we can't just ignore it forever, can we? I mean, we have to remove it from the queue. Or do we just let it pile up? Because we can skip polling it entirely, right? But like, WM Paint and W mouse move we can skip entirely. But if this message, I don't know whether this message is a generated message or not. If it's a generated message, then we could skip it entirely. If it's not a generated message, I don't know that we can skip entirely because I don't know if it would just fill up on our thread the whole time, right? So that's kind of, right? It's kind of a little bit tricky. So, you know, if you imagine extending this routine out a little bit to something that was like dword skip messages, right? If you imagine us saying here, well, all right, we want to skip WM Paint, we want to skip WM Mouse Move, and we want to skip whatever the heck OX738 is, that's not even a message that's supposed to exist, then we could do a thing here where we do a for I loop over like skip index equals 0, you know, skip index equals array count, skip messages, plus plus skip index, like so, and then we would just do this, right? Where each time through we would say, all right, like we're gonna start the messages at like last message equals 0 or something. We're gonna start the messages at last message. We're gonna go to you know, skip -1, and then we're going to set last message equal to skip +1. So it will hop over every time, whatever that thing was, right? Seems reasonable enough. And, you know, I guess we end on that. It'll end at FFFFFFFFD, but I'm okay with that, if that makes sense. So, yeah, I think that would be fine. The other way we could do it is via ranges, which maybe is better. I don't know, but whatever. So anyway, in here, when we're doing this, yeah, we could just get rid of all of this code now, and it would just look like this. So we would go through and try each of the ranges as we go, and that skip message is obviously just like skip messages, skip index, like so, right? So that would skip message 738 entirely, so it just doesn't ever get there. And yeah, I think that's fine. This is complaining that we might not initialize this, but we will. I mean, I'm not sure why static analysis can't figure that out, because it should be able to see that you always get in here. This is a constant value. So the static analysis in the compiler must not be able to poke through that for loop, which is fine. I'll clear it. So now, in theory anyway, in the vaguest of theories, if I run this, I should be able to put this back in, actually. So now if I run and here we are running, if I do lighting and then switch back and do this stuff, I don't crash anymore, right? So there I've run the lighting. I can come back here. I can say, hey, pause and capture frame, and all that works. So it looks like, yeah, we can just skip that message probably, and then we don't have to care if Windows starts spamming us with it for some reason. Maybe it's a generated message, maybe it isn't. I don't know. I mean, that's just like, yeah, I don't know what to say about that. I guess there's one other thing we could do. Yeah, I'm not going to do it though. All right, so let's go back to let me see about questions. And there's someone else posted an additional, looks like the same info though. All right, so that was a kind of frustrating thing to have to do, but at least it actually worked. So, you know, at the end of the day, I guess that is a good thing. I'm not going to complain. We were able to figure out what was going on. It was pretty bizarre, but, you know, there you are of it. If you take a look here at our rendering information, we can now start to ask the questions that I actually wanted to. Like, here's the fragment shader, for example. And we can look up stuff like, you know, the lookup sampler or whatever. We can kind of go in here and see what the value actually is, what the values are for these things. Right now we have them commented out because I had tested that to see if that would help, which it, you know, turned out to not having to do. Oh, no, we don't. They're commented in. So at least in theory, now that we kind of got all that cruft out of the way and figured out what Windows 10 was doing to destroy our application, what just happened there? Why did that? There we go. Paste, please. Thank you. It would be nice to know why Windows has started sending a 738, an OX 738 message. I mean, that's just totally effed up. But at least we fixed it. So I guess tomorrow we'll be cleared to actually debug our lighting like we wanted to. And we got rid of the thing that was standing in our way. We got rid of RenderDoc. Unfortunately, that didn't work. Nsight does appear to be working. So we can now, and we got rid of the Windows 10 thing that was preventing it from working. So we should be good to go. So I guess I'll end the stream there. Abarishu, what do you mean by generated message? So this is kind of a confusing aspect of Windows, but what happens is when you call peek message and get message, right? The intended behavior of those functions is that there's a message queue for your application in Windows, and it's per thread usually. So whenever whatever thread you're on, when you call the functions to check messages, it looks at the message queue for that thread, and if there is a message waiting in the queue, you get the message back, right? And that's exactly right. That's what you would expect. Nothing weird about that. But that is only for certain kinds of window messages, the majority of window messages. For other special kinds of window messages, such as paint and mouse move, instead of that, what it does is if you ever ask for one, meaning if when you call peek message and you pass the range and the range includes paint or mouse move, if there are no messages in your queue to give you, so if there is nothing actually in the queue that someone has posted, like a WM size message or something, then it will generate a paint and a mouse move message for you. right? So it will basically create them to tell you you need them if the mouse has moved or your window has been obscured and needs to be repainted. It will generate them on the fly. Now, we don't use WM Paint or WM Mouse Move, so we don't actually want it to generate them. So we just say don't bother, right? Because it's just wasting work and causing this loop to have to go around a bunch more times, potentially, when we really don't want to. Uplink Coder says this seems to be a known bug since Windows 10 build 1703. How is that possible? What were they doing posting a Windows message that's in the WM user range? That's nuts. That's nuts. Raymond, where is Raymond Chen? Raymond Chen, what is OX738? Tell me, why is Windows posting OX738 messages to applications that's in the WM user range, Raymond? What is going on? How is the performance of the from scratch written renderer compared to OpenGL? We haven't updated the from scratch renderer yet to do 3D. So it still runs the old 2D path, so we don't have a way to compare the performance yet. How in 4Coder you make possible to have type def highlight? I recompiled it from source. I actually, we licensed the source code to 4Coder from Alan. Since it's the editor, we use it in Molly for everything. So we can just rebuild it if we need to. I don't know if there's a way to do it other than that. There might be. There might be keyword highlighting, but at the time, there wasn't programmable keyword highlighting. Let's see if we've got any more questions about what we're doing today. Crab, if this has been answered many times, I'll dig back through YouTube, but when and why did HMH move from being fully software rendered product to using graphics APIs? So I don't remember why, but I think it was just because we wanted to be able to do more like high-res rendering and be able to use as many sprites as we want and not have to care and stuff like that. So we, at some point, we just did both, so you could switch between them. We've added some 3D stuff now, which our 2D path doesn't know about. So we'll ping pong back there at some point and update it so that the software render version will match the hardware render version as well. So in the end, we will run on both equivalently. The only difference will be that the software render is always going to be much slower compared to the hardware renderer. That's obvious, right? Because it's not able to use most of the power on the machine. Any chance to run the game with the lighting actually on, just for old time's sake? No, not till we fix the new one. How would you cast a pointer and call it directly without an extra type? How would you cast a pointer and call it directly without an extra type def? So you're talking about like a function pointer? I'm not sure exactly what you're asking, but I'll try to answer it. So here, I'll just make one right here, right? So I think what you're saying is, let's suppose that I had a function. Correct me if I'm wrong. Let's suppose that I had a function like this. Is this what we're talking about? And you want to call this function. So is this what we're talking about? And then you have a thing that's like, oh, okay, I've got a void star, let's say. That's a pointer to that function. Is that roughly what we're talking about? So you've got this situation, and you want to know how you call it without making any kind of type def. So you want to do something where you're going to call like foo pointer 5. Is this what you're trying to do? And then it says, oh, I don't know how to do that. Is that what we're talking about? Resantic. How about 2D? How is the performance there? Just go back and look. There's a whole bunch of streams where we were doing that. We didn't do like a fully optimized one, but it ran reasonably. Okay, yeah. So this is what he wants to know about. All right. So if you want to do this, it's really kind of difficult to do because this is where the C way that they use declarations is just very counterintuitive and difficult. But the basic idea, right, the way you would do it, like start this way. So suppose you did have the type def, the thing that you don't want, right? The thing that you don't want looks like that, correct? So if I wanted to be able to call this without having to worry about, like, without your constraint, then what I need to do here is I need to cast it inside the parentheses here, right? So before it tries to use it as a function, I need to cast it in here, right? But that will work, right? And we can verify that that will work because I can actually make it happen. Here, right? So we're definitely calling it. So now the question is, well, what if I want to get rid of this type def? Well, what I would need to do here is I need to figure out a way to put the information from the type def, which is effectively this, right, in here. So what I'd like to be able to do is that, right? But it's not quite right, because if you look at what happens here, it's like, all right, the way this is going to get read is going to get read in the wrong order, right? Foo pointer is, right, a pointer to a function taking an integer returning a void, or sort of like, well, not really, because it's going to read it in the opposite direction. So, like, doing it exactly that way doesn't actually work, right? Because of the C order where the parenthetical for the argument list, I'm not sure how to say this, it goes in the other place from where the type name is. I'm not saying that very well, but like, right? I mean, it goes after the type name instead of before. So the pointer part, would have to have like the argument part has to go after it, right? How you actually make it understand how you actually make it do the cast, I'm not sure. Because as you can see, like, I believe this is the correct form, right? But it doesn't actually allow you to do it. So that should work, maybe. Yeah. So basically, this is the form for a function type, right? And we need a pointer to a function type. So what it read here was like void star, returning a void star, an integer. By parentheticalizing that, I forced it to read the star first. So it goes like pointer to a function taking an integer, returning a void, because it's inside another set of parentheses. I know this is really weird. But you can kind of imagine that it's reading an invisible identifier name inside the innermost set of parentheses, I guess is the best way to say it. So, sorry I'm doing such a bad job explaining this. Let me do it from the let me do it 2 ways and see if that helps make it clearer. Maybe that was already clear, but I doubt it was, just because it was really confusing. So what's going to happen inside the C compiler is it's going to make an abstract syntax tree that describes what the heck is going on here, right? So inside the compiler somewhere, here's my Milton-ness. What day are we on? 406? So inside the compiler, it's going to have to make an abstract syntax tree. And so, you know, abstract syntax trees have a binary descending notion to them that makes them different from a left to right reading order, right? And so it's worth thinking about this just for a second, because this is why these sorts of things come up. The reason these sorts of things come up in C and other languages as well is because there's a fundamental difference between a linear line of text and how a compiler ends up interpreting that linear line of text when it actually goes to process it semantically, okay? And so you can think about operator precedence as a very common way in which this happens. So for example, you may see a linear line of text that is A plus B times C plus D, right? And if you were to look at this as a line of text, then the order of operations that you would perform is very clear. It would be to take A, right, and add B to it, right? I would then take the sum of this, which is like A plus B, right? I produce the result. Then I would multiply by C, right? So now I've got C times A plus B. And then I would add D to it, right? So that's what I would actually end up with if I was interpreting this as just a stream of things going from left to right. I would do A plus B, that's a value, times C, just like I was hitting them on calculator buttons. So it does the A plus B first, then it does the times C, then it does the plus D, right? But that's not how the compiler wants to do it, because it's trying to imitate how math is notated. So we all know that there's like an implicit idea that multiplication will happen first and then plus will happen, because that's the math way, right? So instead what happens is when the compiler parses this, it uses what it's called operator precedence, which is which operators bind together first, to create a different look for this expression, right? And there's 2 ways that a compiler could do this. It doesn't have to do it with an abstract syntax tree, which I'll talk about in a second. It can actually do this with just straight up stack parsing, right? It can do something by saying, well, I've got an A and I've got a plus, right? I know that a plus might be a high precedence. A plus might be an operator that happens after certain other tighter binding operators like times. So what I'm going to do is I'm just going to push like A and plus on a stack, and then I'm going to see what comes next. And I get a B, and then I get a times and a C, and on the stack I then say, oh, okay, C times B is like a totally fine operation for me to perform because there's nothing that can happen that's tighter binding than that, let's say. So then I just compute that and then leave the new result of that, like B times C, on the stack, right? Then I see the plus, which I push again, and I'm like, oh, this plus, in fact, you know, you could even think of this as the more general case where you don't have to make assumptions about anything. I just push B times and C on the stack. I see the plus. I know this plus is a higher precedence than this times, or I should say lower precedence than the times. It depends on how you want to define your precedence there. It's looser binding. So then I can go back and say anything that was previously, you know, less, you know, a tighter bind than me can now get collapsed, right? So we can do things like that. You know, it can have sort of a stack logic to it. Like that's where, like, I don't know if you've ever heard of shunting yard. It came up on the stream one time. I'd actually never used this algorithm, but it's kind of neat. It's a Dijkstra algorithm that actually just like processes in order. You don't have to build a tree. You can build a tree if you wanted to, but it can just process expressions in order, and it knows when to collapse each precedence based on what it sees, right? But anyway, the point is, at some point, usually compilers that want to do more complex operations, they don't try to execute everything in line like that. What they do is they try to build a tree that says what's going on. And what that tree looks like is it looks like an order of operations style sorting of the information. So the most high-level constructs we have here are the pluses. So the first plus would be here, and it would have an A on its left, and it would have everything else on this side on its right, right? Now, again, the most important thing on this side is a plus. It's the most like coarse-grained operator. So that will have the B times C on this side and the D on this side. And on this side, then we would have the times operator and we'd have the B and the C, right? So this expression, when a compiler looks at it, the compiler actually looks at it in a very different way. It's going to turn it into, using those operator precedence rules, a tree that looks like this. And then when it's thinking about the tree, it's actually thinking about it like this. So when it goes to generate code, it's going to say, oh, I've got to add two things. And it's going to look down the two branches to say, all right, I need to prepare what's going on the left side and prepare what's going on the right side so that I can do my add, right? And then it will, progressively go down the tree and wind back up. So then you end up getting all the way down to the times A plus B. It will create like the mul A, B, right? And it's going to put that into a location that the plus can then do, right? So then it'll do an add, whatever this is, whatever the result was here, right? It's going to add that the R and the D and going to put that in another result, right? Result 2 or whatever. And then it's going to do the add of the result 2 and the A and put that in the final result of this tree, right? So it kind of goes down the tree and then resolves the tree on the way up, outputting each of the sort of like assembly instructions it will need. This is not real assembly language, obviously, but you get the idea, right? So the same exact process that happens there that hopefully is fairly intuitive with an equation, how that happens, right? Because I have to turn this into a linear series of operations on the CPU, and I need them to go in the order the programmer expects. If B is times C is supposed to happen first, I better not add A and B first, or I'm going to get the wrong result. So it needs to build a tree that reflects the correct order of operations. That same process is happening everywhere in the compiler for all things, not just operator precedence. So when you see something in the compiler like a cast, so let's say I see something like this. I will get something that's like, okay, there's an equals operator, which is this right here, the most granular thing, right? I've got a target of the equals here, which is A, and then I've got a cast expression here, right? Cast expression. The left side of the cast expression is the keyword int on the inside of here, and the right side of the cast expression is 6.2f, a constant, right? This is a keyword. This is a variable. This is a constant, right? So then when it goes to execute this, it's like, oh, okay, and execute's the wrong word, generate code for it. It goes, okay, I know, I've got some information about A from up above in the code. I know where I'm going to put this. Okay, I've got to do a cast. It's a constant cast, so I can cast this maybe just right now inside the compiler. I don't have to actually generate information to cast it, right? And I know I need to cast it to an integer. I know what an integer is because I have a type table that tells me an integer is a 32-bit value that's signed and blah, 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 right? So that's what's happening, okay? So now we finally get to what we're trying to write here. And we'll take what I wrote the first time and we'll take a look at it a little more carefully. And then we'll look at how I fixed it by putting the parentheses in there. Right. So the first thing that I wrote was, all right, I want a void star int, right, like that, foo pointer, right? And this whole thing was inside a set of parentheses, but we don't really care about that because that was just so we could call it as a function. We really care is getting it to cast to the type of a pointer to a function. So I wrote that one first, and this one casts it to an actual function, which you can't do. You can only cast to pointers to functions. You can't cast to a function, because that would be like this whole block of data and code. All right. So what we know here is because of these parentheses, this informs the compiler that it has a cast expression. So these two things become the cast expression, right? So then it needs to make sense of both sides of the cast expression. It's sort of like if I had an operator here, right? A magical operator that meant cast, I would write it like this. Right? And this operator is the cast expression. But we don't write it that way in C because there isn't an operator for cast. So instead, it's if you parenthesize a type name, it is a cast, right? So that's what happened, this cast, right? So those go away, and we just have this on the left side and this on the right. Well, okay, so this is just a variable, so there's nothing interesting here. So now the question is, what happens over here? It's got to parse this definition somehow, right? And it has to figure out what that means. But all it sees is a type on one side, void star, and a function parameter list on the other side, int, right? So what it thinks is going on here is, oh, okay, I'm defining a function prototype, right? And I'm defining the parameter list on this side, right? So this is the param list, which just has int in it and no more parameters. Like the parameters would chain out here if there was comma, char, star, whatever. And then it's got a return type over on this side, right? And that is a pointer. That is a pointer to, there's only one parameter for a pointer, to a void, right? So it's function, pointer here, to a void. So what it sees when we go to cast this is it sees that this left side is completely, it's just a line of type information. So it's going to take it in order, right? It's going to read it basically this way, and it's going to say, pointer to a void, and so it's like, okay, that's the return value. And when it sees this integer here, it's going to say, oh, okay, that's the param list, because when it sees the parentheses, I should say, it's going to do that's the param list. It's going to read it out, right? So that's what it's going to think. However, if you introduce a parenthetical there, right? So how I fixed that function, right, was I said, oh, okay, void star int, right? Then what's going to happen is because it builds these from the innermost part out, right? From the innermost part out. And I really left one part out here that, again, it's hard because C++ and C and C++ just use this syntax. It's very difficult to grok. Remember how I said, this parenthetical is an implicitly, like I wrote a cast operator. Well, imagine there was another operator that's like a function operator, right? Well, what would it look like then? Instead of void star parentheses int, and right in here, there's a magical function operator. That's the part that's so confusing. There's like func is right here. So it's really void star keyword func. Like this is a keyword. It says make a function, right? And the parameters come after it or something, right? So if we had this magical func operator, it'd be a lot easier to see what was going on because there it is, right? And the things that go on this side of it are the parameters, and the things that come on this side of it is the return value, right? That makes sense. So what we're doing effectively when we add this parentheses is that magical func, the operator's now on the outside, right? So it's going to start with the pointer because it's the most parenthetical thing. And it's going to flip the order of these two things. It's going to say pointer, no, right? And func goes here, Does that make sense? But it's really hard to see that because it's this parentheses that is the de facto func operator. It's the fact that we have a parenthetical param list that makes the function. But what that does, see, the parser works from that, the way that C-type parsing is designed, right, is it works from the innermost thing out. And that's exactly like what happens, again, with that operator precedence. The innermost parenthetical gets evaluated first, even if it's like a plus, which normally should be, pluses should happen after stars, right? So normally this plus would have happened first if it was A plus, normally this plus would have happened second if it was A plus B times C. But because we parentheticalize it, the parser starts on the inside, right? And it will do that first when constructing the tree. And that's the exact same thing that happens here. The most parenthetical thing is the thing that starts the type declaration. So it reads star first before ever getting to the parenthetical list that says create a function. So when you read one of these, if you see void star int, like so, think this is a function taking an integer, right? I should point to this. This is a function taking an integer, returning a void star. Why? Because function has the most powerful granularity there, right? It's the thing that will appear at the top of that tree. So you start with it just like you would start with plus at the top of the tree, because it's the most, I'm using the wrong, I don't know how to say it right. It's the coarsest grain operation. Func is the coarsest grain operation in the type definition, right? So we start by saying func. Then we say, okay, what's on either side of the func? What's the ret value? It's this. What's the parameters? It's this, right? But if we were to insert a parentheses, then what we're really saying there is, oh, just like we parenthesize plus expressions to make them happen first when normally they would be the coarsest thing. This parenthetical makes the pointer the most important first thing. And it happens first. Then we read the next thing outside the parentheses, which is the func, right? Which is this, because it now has the highest coarse, the most powerful coarseness. Does that help clarify that at all? I know this is really weird and complicated, and it's one of the most hard things to understand in C. It's also one of the most hard things when you're writing a C compiler to get right, is going, wait a minute, it's not actually. The most hard thing is probably the preprocessor, because the pound define macro syntax is so messed up. But it's one of the hardest things to wrap your head around, because we all kind of intuit when there's actual operators we can actually see. It's a lot easier to understand how this gets broken up, because you're like, oh right, pluses happen after time, so they come up higher in the tree and whatever. But this stuff is really hard because there's no operators. They're all implicit in the parentheses. Tutor, I was doing some compiler things a few months ago. Could a parser programming, maybe operator parsing only stream? I'm not really the one to do that. That would really be a John thing. He's more the compiler guy. He said he would do one time, but he's just, I think he's got enough stuff he's interested in doing right now that just hasn't bubbled up. But, go bug naysayer. Can you explain how you would fix some stuff such as the fog in PUBG? Is the fog broken? What do you want to fix about the fog? Do you want more realistic fog or something? What Blackboard program are you using? There's a program that was written specifically for this stream by Sergio. Serge. It's SERGE_RGB. He doesn't use Sergio as on the chat. So on the chat, it's Serge RGB. I don't know if he's probably not on today, but he wrote this program called Milton. And it's pretty cool. It's a great blackboarding program. Highly recommend using it if you're streaming. And you can get it for free, and it comes with source code. So it's pretty awesome, actually. All right, I think that's it. So I'm go ahead and wrap it up. Oops. Yeah, I try to avoid that stuff. We've never covered this on Handmade Heroes simply because it's just ridiculous. Like, I don't even think people should bother learning it unless unless you're doing C compiler stuff, because just make the type def, make the type def. It's easier to read. Everyone understands that. Whereas if you try to put a function pointer in a cast expression, it's just nuts. I mean, you can imagine how nuts this stuff gets, and and nobody knows why. Like, most people don't understand what's going on here, and why would you? It's like a compiler artifact almost that's how that works. Like, I don't know the function precedent. Like, that's remembering what precedence function versus pointer is in the type declaration syntax of C is just not. It's not the thing that a programmer should really have to spend their time like dealing with, because operator precedence in the math sense, it's logical for that to be something the programmer has to know, because they have to know how to do math anyway. So the fact that you need to know that multiply happens before plus, before addition, that's just obvious. You're not burdening the programmer with that, because if they didn't know that, then they don't even know how to do the kind of basic math they need to know how to do to be effective at programming. Anyway, but in the case where you've got like something like these weird type definitions, they're just dumb. Like, type definitions don't branch. Like, they really just don't, for the most part. And so it's dumb that they aren't just a line of things. Like, it'd be way more sane if C looked like that, right? Or better yet, like that, where it's like 5 integers is foo or something like that. You know what I mean? Like, it would be better if you just could read the thing in order and it was what it said, right? It's like pointer to 5 integers is a lot more legible than what we ended up with, in my opinion. But it's like, at this point, it's the horse is out of the barn, so it's like you can't really change that now because we're all so used to, typing this that I can understand why you got to keep it, but it's not good, I don't think. All right, I'm going to wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code. Now, why we just crashed Windows 10, apparently, by closing some applications, I don't know. But that's kind of par for the course today. It's been a real unreliable programming day, but not because of anything we wrote, largely due to Microsoft and graphics card stuff, but oh well. Anyway, you can always go to handmadehero.org and pre-order the game. It comes with a source code if you want to play around with it. As of tonight, when I update the source code, the source code for Handmade Ray should also be in there. So if you wanted to take a look at the ray tracer we did as a test stream while we were working on getting the streaming setup working, that'll also be in the source tree now, both in the GitHub and in the downloadable zip files. So that should be it. Yeah, until next time. Don't forget, we have a schedule about that tells you when the stream's going to be live, and we have an episode guide if you want to catch up on old episodes. I referenced that in the stream today, actually. I think in the pre-stream I pointed someone to it. So don't forget to check that out as well. That's it for today. Thanks for joining me, everyone. And I guess till tomorrow. We'll be back here at what time? I think it's 10 o'clock tomorrow, Pacific Daylight Time. Pacific Daylight Time, right? Yeah, I think it's 10 o'clock Pacific Daylight Time tomorrow. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.